Thank you, everyone, and welcome to our expert panel, Disaster Recovery That Actually Works. We'll take a few more moments here and let everybody kind of come in and join us. If you were trying to join a little bit ago, StreamYard was down. We had their own disaster recovery issues, but thankfully they came back up again right in the nick of time, and we were all scrambling behind the scenes to be ready, and thankfully it all came together. So again, thank you to everybody who's coming in. We're seeing the numbers climb now, so this is terrific. Again, thank you very much for all of your time and attention. And before we get started, I'll make another announcement once we begin. But all this content, these slides, will be shared with everybody. We'll also try to leave plenty of time at the end for Q&A. So please feel free to collect those questions, and we'll absolutely have a chance to answer them as we get towards the end of the presentation. So give it another couple of seconds here. Let these attendees come in here and just get ready. And again, thank you very much. We actually moved this topic up in our Thought Leadership series because it's so top of mind for everybody. What's happening certainly over the past month. Obviously, we all know in different disaster recovery instances and issues that have happened. So it's very, very timely. We're excited to be able to pull this off in a very short period of time. And again, I'm your host, Justin Barnes. Very grateful to be here today and joined by three distinguished panelists and also experts, not only in technology, but also disaster recovery. So we'll go ahead and launch off here. So again, I'm Justin Barnes, and I'm joined by Donnie Wilson from Amazon AWS, Mike Thompson from AMD, and Jeremy Brown from the Atayo Group. Again, three great experts, not only in technology, but specifically in disaster recovery. So very excited for the opportunity to bring this to you today. And again, all of these slides, all of this content will be shared out with everybody in the coming hours after this show, and certainly throughout tomorrow. So a lot of great content that you're going to hear. Again, we're going to take our time. We'll spend about 45 minutes or so going through the content, giving plenty of time again at the end for Q&A and some highlight wrap up. But we're going to cover really why disaster recovery matters, current issues regarding disaster recovery. Again, some of this is very top of mind to what we've seen out in the industries, even globally. Some of the pain points, and then specifically optimizing disaster recovery cloud, cost, performance, and energy consumption, some key strategies for effective disaster recovery, best practices for implementing disaster recovery plans. And again, there's some options here that we're going to bring to you, a landing zone strategy, disaster recovery landing zone strategies, and then certainly some highlights from the panel. And again, we'll be sharing all this right now with everybody. So again, without further ado, I'll turn it over to Donnie Wilson from Amazon AWS. The floor is yours, Donnie. Thank you, my friend.
Yeah, thanks, Justin. It's pretty common today whenever we're working with customers, we get the opportunity here at AWS to get exposure to a lot of customers, especially in the healthcare industry. And whenever we're asked often about, disaster recovery or business continuity in general, the why comes out. And so when it comes to disaster recovery, you got to think about who your end customer is and really who you're serving. And that's the patients, both as a patient myself, as well as, various family members and friends. It matters that healthcare systems are becoming more and more dependent on technology. And while the providers themselves are able to deliver care, it really does kind of like, we want to highlight the fact that there have been statistics and recent reports that have came out recently stating that mortality rates, for example, have increased during these unintended interruptions of technology. And so it really is a challenge. It puts a burden on the organization, but the main challenge is patient care and lives, in general. The other part of this that really kind of plays a huge factor is, healthcare systems run on a fairly thin margin, and the cost of both balancing out what disaster recovery and those capabilities are with the cost of the average outage now crossing, $10 million, for example, it really plays a huge factor in our ability to then further innovate in the healthcare industry, make sure that the operations continue as they're supposed to, while the healthcare system does have to maintain enough margin to reinvest, take care of patients, and continue operations. So as we kind of look into disaster recovery overall, it really does start with the people and the process. I'd say the process or the strategy in general has to be in place first. So as we kind of think about the various capabilities of an organization to build out a disaster recovery program, for example, they're often faced with, leveraging the same individuals that do the regular technology work that have to then implement the backup strategies, for example, or the technical pieces of those functionalities. So a lot of times there's individuals in the organization that are, in fact, in the IT department trying to manage things and implement these disaster recovery strategies that really are maybe not even formally trained. They're just more technologists. And so it's really important to set the overall strategy at a high level, make sure that the leaders in the organization, in fact, are helping set that strategy, those policies and procedures, working on the business continuity plan in general or disaster preparedness, and then ultimately leverage a technology to solve a problem, not try to buy a technology and then work to find a problem to solve. And so it's really does help us whenever we think about working backwards from the challenge itself. The other part that I would like to highlight here is that a lot of these interruptions in care, they do spill over into the community, for example. So if one healthcare system does experience some kind of a challenge, part of this is reaching out beyond that. Like, what do you do if you divert patients to another organization? And what is the financial impact on your organization? What is the patient care impact? Is the organization able to continue delivering care? But ultimately, at the end, we want to make sure that our technologists are trained, that we have somebody that's dedicated and focused on this, ultimately that they are leveraging new technologies and automation to the best of their abilities to make sure that they're testing and defining these policies and procedures, as well as implementing the technologies on the back end. So as we kind of think about the overall pain points that we face in disaster recovery, it really does kind of allude to the idea that we have to have an overall comprehensive strategy in place. So the governance, for example, whenever I was working on the provider side, I've got plugged into the disaster preparedness teams. I would go through the organizations, different departments of the organizations. We would work with the JCO departments, and ultimately, what happened was we focused on what was critical to deliver and continue delivering care. And it was the foundational things from facilities like, for example, for example, like power, air conditioning, for example, lighting in critical areas. Those were all things that we had to kind of work through, but very, very often it didn't focus on like the IT department properly. And so what we would do is work backwards from that, figure out again what was needed to deliver care. And then as organizations became more and more dependent on technology, especially in clinical engineering departments, for example, we would work together to ensure that those systems were in fact built in a resilient fashion, maintained proper backups, for example. And then of course, I think the key here is that backing up a system by itself is great. But if you do not have the ability to restore it over time, if you do not have the ability to test that restoration, it does put you at a disadvantage whenever a situation happens, for example, and you need to restore that, and then that backup's not available anymore. Or maybe you didn't think about the impact of disparate systems that were dependent, right? So having all these conversations and functions up front leads to the ability to provide a continuity care. It does help mitigate against the risk of increased mortality. And then, of course, the reputational impacts. Healthcare customers today, patients, they have the ability to now shop around more than ever before. And the cost of reputation here is fairly significant for the organization. So everything, looking at the whole entirety of the challenge, everything from basically winning grants for some kind of a research project through just the simple community impact and patients having the ability to select who to go to, it matters. The organizations can prepare and essentially recover whenever an unfortunate event does happen.
Yeah, and I also know Mike and Jeremy, you guys also have some follow-on thoughts here, but certainly, Mike, what are your thoughts? Yeah, to that.
Yeah, agree quite a bit, and some of my content goes into this, but I think Donnie mentioned a couple of things with respect to the financial impact of implementing disaster recovery plans as well as disaster recovery infrastructure. And that financial impact is largely affected by the type of infrastructure or the type of cloud instances that customers and service providers choose to land those workloads on. And so I would say that when you're planning your disaster recovery transformation, you have to think carefully about what instance types do you land those on, and there's a 27 to 45% OpEx impact that hinges on that choice.
Yep.
Yeah. And so I think the real value that AMD brings to disaster recovery, new deployments or existing optimizations, is the ability to optimize both cost, performance, and energy consumption. And that really comes from a few things. There's a few technical drivers that AMD provides for the instances that these workloads are running on. And most of that is derived from what I call performance-driven economic benefits, the first bullet that you see here, where if you compare previous generation, say M6i instances, if you speak processor types, that is Ice Lake. And if you compare those to M7a instances, on average across a wide range of workloads, lots of general IT workloads from web and app servers to video processing to a lot of back-end databases, on average, if you modernize from M6i to M7a, you get double the performance at 37% lower cost. So that's a pretty big return, both from a user experience and a time to decision perspective, because your performance goes up so much. But you also get those benefits while lowering your net job cost by 37% on average. And then for some other applications, if you just want to optimize general IT cloud OpEx, on average across those applications, you can save 27 to 45% simply by selecting AMD EPYC instances. That would be M7a, R7a, C7a, or maybe the 6th generations. You can see the A in there indicates AMD powered instances. And in particular, for licensed applications, the 45% end of that range is a TCO optimization that can be done for licensed applications, like SQL Server is pretty common in the healthcare industry. Some other industries, they use other major databases, like financial services uses DB2. And because you get that double the performance, that means you can cut your instance size in half, which has a dramatic impact on the hourly cost while boosting your performance 23% and reducing your OpEx by 45%. So those are some of the scales of optimizations that you can get simply by selecting AMD powered instances. Now, one of the other large expenses that I'm hearing a lot about from customers around the world right now is VMware. I have a lot of organizations, both service providers and customers, coming and saying, hey, help me. I want to move my virtualized environment to more of an open source model. And so through partners and with AWS and with AMD, we have some programs in place, such as the one here for Atayo for disaster recovery, where you have easy landing zones. We have partners to guide you through as you develop the architecture of your infrastructure, as well as do the execution of those transformations while doing performance, cost, and energy optimizations like we've been talking about. So please reach out if you are looking to reduce the cost of your VMware environments. I see a lot of customers, instead of trying to migrate the whole thing at once, which is sort of a boil the ocean problem, they will go in and look at their largest, highest OpEx applications like SQL Server, for instance. And if they peel that out and land it in either native AWS virtualization or potentially Red Hat OpenShift virtualization, their costs go way down and they have a more flexible application that could be migrated around without the challenges of proprietary software that sometimes we find. And then outside of that, so looking at the energy efficiency, I see energy efficiency actually starting to drive a lot of customer decisions these days, especially in Europe, where energy availability and cost is as challenged as it is more challenged than it's been in decades. And so by choosing AMD EPYC processors, not only are they high performance, they're also very, very power efficient. And here, if we compare Xeon Ice Lake to AMD EPYC Genoa, that's a 6th generation instance versus a 7th generation instance, you get 2.6x better performance per watt. If you compare same gen, it's about 1.7x. And so the power consumption is dramatically lower. And we also have partners that can help you assess all of those aspects, the performance, the cost, as well as the energy efficiency. So in a nutshell, that's the value that AMD brings to these disaster recovery deployments or transformations for optimizing cost, performance, and energy consumption all at the same time. That's it in a nutshell.
Excellent. Anything, Donnie, that you would like to add to that, or Jeremy?
No, those are excellent points, right? I mean, compute super important to be efficient from a cost perspective, and there's lots of dynamics when you think about DR. There's lots of things that that are DR events, right? So whether it's weather related or human related or ransomware, right? All of these things, in a lot of ways, dictate certain responses to your recovery actions, right? So
yeah,
that then in itself either is going to, you either need to put yourself in a resiliency position or recovery position, and however you do that, the compute costs matter, right? If you're scaling into an attack, for example, or you're having to scale into a failover into another region in AWS, just to be able to weather the storm, so to speak, right? So compute cost is certainly important, and doing that as efficiently as possible, and also the cost, as we said earlier on in the conversation, the cost of just doing DR in general, right? Maintaining pilot light infrastructure and those kinds of things, all super important when you think about the types of processors, the types of instances that you run those things on in AWS, relative to other services that AMD, is underneath the covers with respect to managed services on the platform as well. So super important.
Yeah, and to add to that just a little bit, we always talk about optimizing our compute environments in AWS, but it's not just the compute; it's everything in general. We try to work with customers to optimize a lot of different things. But what I love about painting this picture is that the margins that we talked about before are thin. So every dollar that you can save allows you to do something else with it, whether it's additional patient care, whether it's saving money on your compute costs. It allows you to reinvest into your disaster recovery strategy in general. So optimization is something that needs to happen at a continuous basis, and working with folks like AMD and Jeremy to optimize the entire AWS environment really does play a significant role in being able to reinvest back in these efforts.
Right. I think that's a good point you made, Donnie, the reinvestment. I wanted to come back to that. And so, while the folks who are deploying the workloads, they might not care so much about what happens to that overall budget, but for those who are responsible for allocating budget and managing budget such that they can pivot to take on new applications or solve new problems over the course of a fiscal cycle, that reinvestment can be pretty significant. So just across a lot of industries, healthcare included, 2/3 of their spend is on general IT overhead. It just subtracts from the bottom line. It reduces profits. It consumes more OpEx than it needs to. And particularly in an era like we're in now, where we have so many new applications, mostly driven from AI and ML and advanced analytics, there's so much innovation in that space that a lot of times corporations or companies or hospitals, partway through a year after their budget's already been allocated and is being consumed, a new application comes up that, boy, do they just have to have. Everyone has to have AI, ML right now, right? And so let's say it's an automated chatbot for customer service on the front end. A lot of times the budgets are already allocated, so that when you find yourself in the middle of the year and these new applications emerge, there's no funding for them. So what do? Just not deploy them? Well, no, the answer with AMD is go optimize of that 2/3 of your OpEx that's going into subtracting from the bottom line. If you optimize that just by the conservative 27%, that's an awful lot of funds that can be freed up to reinvest in innovation. I see that being also a major driver to take advantage of these optimizations during times like DR infrastructure optimization or new deployments.
Yeah, for sure. And that's a great segue into like the strategy conversation, Mike. So as we kind of look at key strategies for building out your disaster recovery program, I think, some of the experiences I've had in the past on the provider side is, I would always come up, we would we would have some kind of plan in place, right? Everybody's got a great plan. But then you go ask for the money, and it's just, a lot of times it's just not available in healthcare. And so we would be asked to do a whole lot of things with a very thin margin, or just, no, not right now. It's not possible. But one of the key strategies for building out any kind of disaster recovery program is to look for that, build that business case, right? So as you work with your partners, your vendors, you come up with ways to save and optimize. You turn that around and put it into a business case, and you show that the value that you're delivering through a capability mitigates some kind of a risk, for example, for the organization, or you tie it to some kind of regulatory requirement in healthcare. Those were probably the two most compelling ways that I was able to build the business case out and enable our initial disaster recovery capabilities. I do remember, the first time I went to the well, I kind of asked for this large budget. And essentially I was told you would have all these resources. But whenever the leadership team kind of looked at those requests, I got deprioritized from a security perspective. They're like, we already have all this stuff. And what was interesting is we had these disparate systems, like I kind of mentioned before on the earlier slides, but we didn't have the processes, we didn't have the people, we didn't have the integration with those applications. And what was really kind of interesting is I documented the risk of the decisions that were made. And then whenever it mattered, whenever something really kind of not so great for the organization happened, for example, we would go back and look at those business cases that were created by the teams. And ultimately what we did was we showed that the risk that would be mitigated was far better to spend the money than to basically have a pay now or pay later model, right? So it's like the picture you paint here is that you're going to pay for it now. And so you got this ounce of prevention versus a pound of cure. And then later on, you're going to pay. So it's kind of like your own healthcare. You're going to exercise now. You're going to bring yourself into a well-being state. You're going to mitigate the risk of having some kind of major healthcare problem down the road, or you're going to basically not do that. And later on, it's become a bigger issue. And so building that business case is really important. Working with folks like Jeremy from Atayo, Mike from AMD, optimize your environment, save all the money you can, turn off the AWS services that aren't delivering the value that you need. Don't turn things on and just leave them running. Like, work with your teams to basically, reduce that footprint as much as possible so that you can spend that money on something that really matters. So all that to say, what are some other key strategies for effective disaster recovery? I think, we'll talk about this to some degree, but if an organization has, a lot of IT shops in general within the healthcare systems will do some kind of an analysis of their systems. But if you haven't engaged in an overall comprehensive business impact analysis for your organization, you're probably not necessarily starting in the best place. A lot of folks that we work with, customer-wise, they are very much, we have some great thought leaders we work with, but a lot of them are inheriting some legacy type of mentality. It's like, well, I'm going to buy a backup solution, or I'm going to buy a storage solution. But ultimately, if they haven't taken a time to kind of prioritize the criticality of certain applications, do a comprehensive assessment. I think the last time I checked, there was somewhere in the neighborhood of about 1,200 applications on average that a healthcare system had. 1,200, but yet, who's going to be an expert in all those systems? So you got to figure out which ones are being used for delivery of care, which ones are the most important, life impacting, which ones are the ones that are going to fall into that tiering exercise to say, these are the top 5, 10, 20 applications out of that 1,200 that have to be protected with the same level, the same resilience, and ultimately, optimize and make sure that they are functioning as they should be. And ultimately, from that point, where to focus your backups, where to focus practicing your recovery capabilities. And the topic that comes up a lot here lately is, okay, I acknowledge, the mentality shift a little bit. I acknowledge we're going to have an outage at some point, whether it's man-made, whether it's unfortunately ransomware, whether it's a misconfiguration or some kind of a glitch in a deployment process. There is going to be an outage. The question is, have you planned accordingly so that you can weather that storm for more than a day or two? The average length of time that organizations are having to function have extended a great deal. And so folks are now not looking at a week or two. They're looking at maybe, how do I deliver care over the last, maybe over like a 6 or even a 2-month period while they recover. And so all that to say is, is the strategies that go into making those decisions have to come from a top-down approach. They have to be prioritized. You can't back up and restore everything in the organization forever. I think my favorite exercise is I went to this first leadership. I was pretty early in this space as a thought leader, and I was attending a meeting, and we said, okay, what are the critical systems? And everybody goes, well, we want everything backed up, like for a year. I was like, okay, so we wrote that down. It's like, okay, well, we want everything built, these critical systems highly available with test systems. Like, okay. And then we kind of started pricing that out for them and said, we can do these things, but here's going to be the cost. And they're like, well, we can't afford that. We're like, exactly. So why don't we take another look at this information now and figure out which ones we really have to have? What's the order of events that they have to come back online? And then ultimately, let's build some playbooks and figure out which ones have to be built resilient, which ones can be down for a few hours and maybe be restored, and then ultimately build the playbooks and test those out.
Right.
So,
hey, Donnie, could I springboard off of some of the
Please.
points you were making there? So I think, what you just described is obviously comes from someone who's very steeped in these systems, how to plan them, how to execute them, how to manage them over time.
Absolutely.
That's a large project, right? And so it makes a lot of sense for hospitals, unless they happen to have someone who is so steeped in the methodologies and best practices, which I think that's the next piece of content, the next slide that we have here. It can make a lot of sense to consult with people who do these kind of things for a living. That's why we have Jeremy here from Atayo, and that's why we onboarded Atayo, in order to provide basically an easy to execute disaster recovery plan and infrastructure. You can, I think, the listeners here can maybe gather from all the details that Donnie just went through that it's a big program. If you use expert consultants who do this thing as a profession, you're much more likely to get to done with a more comprehensive, efficient product that covers aspects of the business that, an infrastructure person doing a migration or whatever might not think of.
Right. Good point.
Yeah. And I like to, that's fantastic. And to that point, I talk a lot with a lot of customers in more of an advisory position these days, but I work a lot with Jeremy and his entire team. They do an amazing job. And what I like to kind of balance it out and say, I like to talk about these things and strategize, and certainly, feel like they're good prescriptive advice. Jeremy and his team actually have to implement and live with it. So I'd definitely love to hear a little bit more about some of the things that he's experienced or encountered, and kind of piggyback into this best practices for implementing disaster recovery plans.
Yeah, it's certainly interesting, depending upon where you're at in the maturity curve with respect to your DR plan and your business continuity plans and all that good stuff. What's interesting is kind of working backwards, right? So the people process technology, as you talk about it, Donnie. If you're migrating to AWS or you're doing something that new, we take a DR first, right? A lot of people don't even talk about DR when they're building out a new system, right? Which is, it's unbelievable, believe it or not, right? So
you're almost guaranteed to get painted into a corner, right?
Yeah.
Absolutely. So bringing that forward early in the conversation, right? When you're thinking about moving to the cloud, or you're building out a new data center, if you're staying in those physical constructs and managing that yourself, you have to think DR has to be there early in the conversation. So I think we see that trend, and that's where we spend a lot of time with customers, getting them to think about that as early as possible, right? So because there is a cost to it, but thinking about it early, a lot of the points Donnie that had raised, very valid in terms of thinking about, you don't want to, as you're thinking about DR early, you don't want to then put yourself into more technical debt just by making some broad assumptions, right? Saying, oh, we'll just back up everything. Well, that gets expensive really fast, right? Or we'll just we'll just duplicate all of our infrastructure in the cloud. That's easy to do. Well, sure, it's easy to do, but there's a right? There's a big price tag that comes along with that usually, depending upon the types of systems and how much storage that you have and all that good stuff. So being smart about it, being smart about the conversation out of the gate, working backwards, understanding what it is, what do we have to achieve, right? Because there's a number of ways to achieve those things in the cloud, and doing it in a very performant, cost-effective way, right? So making sure we're using the right instance types, making sure we're using optimal processing and compute, making sure we're only running the things that we need to run, right? And what's hot, what's not, those kinds of things. We have lots of conversations with our customers around when we're thinking about how we're not only going to build out a performant production environment for you, but then how are we going to recover that environment, right? Where we fail over to, and those types of things to think about. So cost efficiency, super important. On AWS, as we work with customers on DR projects, and there's various use cases. If you think about DR, especially in the cloud, right? You're either failing over from on-prem and you're going to AWS, right? Or you're in AWS and then you're failing over into another region in AWS as a DR strategy. So all those things have to be discussed very early on and architected into all of those motions, whether you're building net new in the cloud or migrating to the cloud. Sure. I'm sorry, go ahead, Donnie.
No, I was going to say it sounds like a lot of the conversation that we get to have working with customers. I always like to say that the best disaster is the one that never happened, and we kind of coined this thing here where we say, the best disaster is the one that you prevented and never occurred. We know that the reality is that this is probably going to happen at some point, right? Mm-hmm. So being prepared, like you said, everything you did, laying that foundation, thinking about like a couple of customers that I've worked with in the past, they have different outcomes based on different scenarios. So in some cases, you see an organization maybe that leverages a hybrid model. They implement some kind of an EHR and maybe a read-only version in a disparate data center and most likely AWS in these scenarios. And you see those folks be able to essentially withstand or maybe have a plan so that if whatever their immediate systems are down, they can either leverage what's in AWS, running this read-only environment. Sometimes they have read-write, or even like an alternate system that they can leverage for their clinical information or whatever. But to kind of go with what you're saying, a lot of the customers, once they experience success in this space, they a lot of times have more confidence. Their teams build out skills. Your team works alongside of those folks to build that confidence. And then, they see what some of the capabilities are in AWS. And again, it isn't really about just saying you got to go all in. It's really not. It's about working backwards from the challenge of your organization and saying, here's the technologies that offer the most value and capabilities to enable the continuity of care. So all that to say, as we kind of look at disaster recovery and business continuity in general, building out those capabilities, working with your teams to develop those playbooks, I guess, how would you see those things evolving over time? Where are places that folks can get started? Mike, like to pull you in on this too, where ultimately, looking at whenever they're migrating applications or considering running alternate pods, they have those abilities to kind of optimize compute instances, reduce the footprint, and ultimately, have success in building out a comprehensive disaster recovery plan. Jeremy?
Yeah, I thought you had a question for Mike. So yeah, I mean, just start having the conversation. Understand what it is you're trying to, what the result, what you're trying to achieve ultimately, right? And then working backwards from that, even if it's just doing tabletop exercises on paper, right? Just getting those things understood, and then working back into that. If you have tier 1 clinical applications and they can't be down, we're talking more about resiliency more so than we are talking DR, right? We're talking about resiliency and high availability. If you have tier 2 applications, they don't need to come up. You have a little bit of a longer period of time that those systems can be down and runway for recovery. Then we can talk about how we can do that in more cost-effective ways, whether that's pilot light strategies or whatever this backup and restore type strategies, there's tiers to that, right? And you're going to have a hybrid approach based on how you tier out those applications. So even just sitting down and having that tabletop exercise goes a long way, because there's a lot of things that get surfaced that even within the current production environment, you haven't even thought about potentially in some cases. Can we recover this application? How is this application architected? How are these systems architected? How many times, Donnie or Mike, have we gone in and, there's simply just things that are hard coded that nobody knew, right? And then you start surfacing those things, and so then you start realizing, wow, there's remedial things that we have to do to even be able to achieve, the result that we're looking to get in a recovery situation, right? To meet that, that 4-hour window of recovery, or whatever, that 4-hour RTO, or that 15-minute RPO, right? That we talk about all the time, right? Yeah.
Absolutely. So you mentioned RPO. I think a couple recaps here. You mentioned RPO. You mentioned diverse roles within the organization, right? So you have different people doing different things. I think it's really important that as you go through these exercises, that you do get perspectives from both the leaders of the organization, but also the folks that have implemented and go through this. So like I said, I think you have a bird's eye view of that in your role working with organizations. But to your point, that will uncover, going through these exercises will uncover gaps in any processes that you may have. And ultimately, testing out those playbooks makes like all the difference in success. I mean, a lot of times, just practical advice in general is how do you become an expert in something? Well, you practice it, right? So it doesn't have to be overly complicated, but as we kind of see a lot of folks do, a lot of times they want to embrace the new shiny thing. So innovation's key here, and so I would say definitely do that. That's an exciting part about working at AWS and with AWS, as well as AMD, who's innovating, like I said, hardware, processors, capabilities there, pretty incredible innovations along the way. But don't do it at the sacrifice of your foundations, right? So kind of leaning into the innovation side of things. Mike, can you maybe talk a little bit about that whole migration strategy and like right sizing, as well as, some of the things you guys are working on to help boost disaster recovery capabilities?
Yeah, there's a couple of ways to come at it practically. AMD has a couple of tools that can help you assess your environment for opportunities for optimization, whether it be performance, energy consumption, or net job costs. And so we have a very quick tool that you can use to assess your environment that is it leverages fundamentally a CUR report, a usage report from AWS, and looks at instances and considers modernizing and or downsizing. Modernizing is pretty straightforward. It's pretty low risk. It really doesn't involve much change besides changing the computer that it's running on, changing the server that it's running on. Whereas downsizing, you can get incredible economic and application benefits from it. But when you do the downsize, there should be a technical qualification of that in order to make sure that whatever applications are running are going to be okay when they move to a smaller instance. We have a tool, it's called the Epic Instance Advisor, or EIA, that looks at a very lightweight telemetry footprint of the application. So how much CPU is it using, memory, network, and so forth? What are those utilizations running at? And then when we have that, because we know the capabilities of the more modern instances, we can do the t-shirt, like a glove fit t-shirt sizing for those applications, such that what's the max utilization it's going to be running at, and do you still have all the resources like memory capacity and so forth, memory capacity and bandwidth, are those resources still available for the fingerprint, the specific characteristics of the applications that you're trying to optimize? And so we have those tools integrated with our partners, with our salespeople. There a handful of the sales teams at AWS have been trained on those. So you can quickly and readily assess the optimization opportunities in your environment. And I've done a handful of these things over the last couple of months. On average, customers, when they evaluate their estates, they have like 35 to 42, 43% cost optimization with performance boost opportunities available in their estates.
Wow.
Yeah.
It's interesting points, right? So innovation and optimization, we've worked with a number of customers, and it's kind of an interesting result where we've actually, through DR, have influenced further innovation in the customer environment and additional optimization just through what we uncover through those exercises, right? Or the art of what's possible in AWS. Hey, we're currently on-prem. We're, DR is a good kind of entry point to cloud if you're not in cloud already, right? So we've worked with a lot of customers where we've literally optimize their environment quite a bit just through the DR exercise, and they realize, wow, we get a lot of bang for our buck, using these instance types, for example, over what we thought we were going to need. Or if you're just doing like for like transformation, translations to cloud, you don't have to carry the technical debt with all the elasticity now that's at your fingertips and those kinds of things. So we've done several large projects where we've introduced a lot of innovation with respect to how the workload is either architected or, things that, we've been needing to do these things, right? And now this is an opportunity for, and we have some commitment to improving some of these things now that we have to achieve this DR result, right? We see that a lot as well, right? So sometimes that exercise unpacks a lot of value that you didn't think was there. You didn't think that you were going to identify with from both an innovation and cost optimization perspective.
Yeah. So kind of recapping here a little bit around the best practices. Obviously, you got to set your strategies in place. You got to have your plans, processes, procedures, your RPOs, your recovery time, as well as your recovery point objectives. You have to have all those defined and work backwards from those. Once you start working backwards from those, you'll understand what the actual cost is. You also, as you build out your playbooks and the various capabilities that you talk about doing and you practice those, you'll see a room for optimization. And then ultimately, I think, to your point that you made earlier, the thing I see work with customers the most that are maybe new to the cloud or getting started with AWS is that they have the ability to test where they maybe didn't before. Alternate production systems, migration and having like the read-only environments, but ultimately leveraging automation, machine learning, to kind of look for indicators of compromise or, in their backup environments, for example, or to protect those, immutability of those backups, but ultimately the ability to automate the restoration or recovery of those processes using new technologies and innovations is pretty critical to making sure that they can, the customers are prepared whenever something like that happens. So kind of thinking about that process, you have folks that are pretty mature in the cloud, maybe, further along on their journey. Then you have those that are kind of getting started. Jeremy, take us into the disaster recovery, best practices from a getting started perspective.
So as I was saying earlier, right, we like to take a working backwards approach, right? What are we ultimately trying to achieve? So business continuity, then that ties into the recovery objectives that then need to align to that. Given the types of DR events that could occur, right? Your business continuity plan is going to say, hey, this is the type of business we're in, or this is where our clinical locations are, this is where our hospitals are. These are the types of things that we need to be concerned with, whether it's environmental, human, ransomware, those kinds of things. And then working backwards from that, then we identify, okay, here's the recovery objectives relative to how we tier systems. So we get in with customers. Super important to understand all the different systems that come into play, the system architectures that are at play, to then work on how do we achieve those recovery objectives on AWS, right? And how do we do that in the most cost-effective way? Posture and that initial foundation in the cloud is super important, right? So if you're not already in the cloud today, if you're not familiar with landing zones, for example, landing zones are that foundational first step to, call it building out your virtual data center in the cloud, right? Working, how do we achieve these recovery objectives? Hey, we got tier 1 recovery objectives. Building out that foundation so that way it can support all the different strategies that are going to be needed to achieve those recovery objectives and support all the different architectures that you're going to have with respect to your applications. You're going to have, you're going to have HR systems, EHR systems. They're largely out of the box if they're not already SaaS, right? Your self-hosting or custom developed applications, right? So understanding all the nuances with respect to those architectures allow us to then, work on how do we achieve that. So as long as we have that foundation in the cloud, we talk about foundation a lot with our customers, being in the right posture, especially in a healthcare environment, compliance, super critical, security, super critical, right? And then how do we not only make that environment, how do we support all the varying degrees of recovery actions and motions that we're going to have to architect for on the DR side of things, to support effectively recovering and meeting those objectives within the environment. So it has to be the infrastructure and the foundational, the network baselines, security baselines, compliance baselines have to support all those varying degrees of architectures that could come into play and support a very effective, efficient failover motion, if you will, into the cloud, right? So landing zones in AWS, Donnie, we talk to customers a lot about that, whole host of best practices that come along with that, and all around, compliance and security, separation of duties, separation of environment, minimizing blast radius, right? When we think about DR, and and I'm just going to pick on ransomware, pretty prevalent topic when we think about DR these days. Not only do you go and you build out all these things and it's great, and we're able to meet all the recovery objectives. You're in AWS, we fail over, we test, but we have to make sure we protect. Right. So bad actors, the first thing they're going to do is delete your backups and delete your disaster recovery before they take you hostage. Right. So making sure we have those foundational mechanisms in place with respect to logging and monitoring and full observability across the environment. And then ensuring as you build out more, hey, we need more compute resources, or we need to scale out the environment and extend the environment to support different new production systems. Right. And keeping those things separate, compliant, secure, and minimizing blast radius across those things. Protecting that data is super important, right? So air gapping techniques, right? When it comes to, hey, we're going to replicate, we're going to use AWS as a DR target, for example, and we're going to replicate our on-prem systems into AWS. We want to make sure that replicated copy is just as protected as the production systems themselves. Right. So, and putting in every precautions we have, to Donnie's point, something's going to happen. Right. So when we think and we sit down with customers, that's how our brains work. We're wired to go, okay, what if, right? And again, working backwards from business continuity, and your recovery objectives helps us kind of hone in those what if conditions. And then from there, just making sure the foundational is secure, resilient, allows us to scale into things, supports the workloads in a performant way, and as cost effectively as possible. In the cloud, we have to architect for cost just as much as we have to architect for performance and security and all those good things as well, right? So again, working backwards, making sure there's a sound cloud foundation to receive data, to restore, to store systems, store data, and largely support the recovery objectives that we're trying to achieve, and doing that as securely as possible.
Excellent, Jeremy. Thank you very much. Any quick last comments, Donnie or Mike? Awesome. Yeah, no, thank you very much, gentlemen. Fantastic discussion. Certainly panel. And so just to give you guys a couple of highlights, but as I go through this, feel free to begin adding any comments that you have or thoughts or questions into the comments section. You may have to exit full screen to find that comment section on the right side, but please feel free to put any of your comments in there, any questions, and we'll certainly get them to the panelists. But, we heard, from the get-go, 28 to 43% increase in mortality rates when there's an outage. So obviously critically important, certainly for care continuity and business continuity. And the average cost of an outage is over $10 million. It's $10.1 million. So very significant to any margin, any organization, certainly when they're watching their margins, like in healthcare and in most organizations. But it takes, as you heard, best practices, the right team, the right people, the right strategy, and certainly the right expertise. Create playbooks, leverage modern innovation, And as you just heard from Jeremy, there are great landing zone opportunities as very simple and organic starting points. So it's certainly something to look into. And this is obviously a great expert team that's here to assist. So again, any questions that we might have, we'll bounce over now to the Q&A section. And again, I appreciate everybody's time today. And again, we'll be sharing all this slide, the recording here, all these slides and everything out with everybody in the coming hours. So please feel free to be on the lookout for that. And again, any comments that you have or any questions, feel free to put them into the comment section. So our first question here just came in. How does AWS ensure data integrity and compliance in disaster recovery scenarios, particularly in highly regulated industries like healthcare? So who'd like to take that one?
I would say I'm probably queued up for that. If not, Jeremy can certainly back me up. So there's the concept of the shared responsibility model that first folks have to understand. So AWS has over 200 different services at any given point that's out there today. And when it comes to data integrity, though, we do support encryption on all of our storage devices. So any device that stores data in AWS, for example, supports encryption. So I would say to ensure the integrity of that, you would definitely want to make sure that you leverage encryption at scale across the entire ecosystem. There's guardrails to make sure that you know which resources are being encrypted, which ones are not being encrypted, and obviously, as you uncover those, you need to make sure you're implementing and remediating those encrypted devices. The other part in a disaster recovery scenario is that applies to maybe your backups as well, right? So make sure they're encrypted, make sure they're immutable. We have a technology called object locked that's part of S3. You can enable that. Your data protection providers and partners that you may work with also typically support that on the back end, whether they're configuring it for you or not, or it's something that they're leveraging. But make sure that your backups are immutable. And then put guardrails in place to make sure that change rates on those backups, for example, are not changing. So should an environment become compromised, should all the multiple layers of security fail, make sure that the backups cannot be deleted, make sure they're immutable, and make sure you have guardrails that if somebody tries to re-encrypt your data, for example, that you have some kind of mechanism in place that will alert you to the abnormal change rate. So all that to say, you have various options inside of AWS as well as with some partners. Definitely, if you don't know what I'm talking about or you need help with that, that is where I would say Jeremy's team would come in to play. Jeremy, do you have anything you want to add on that?
Yeah, just one thing to add, in AWS, as Donnie points out, right, all the services have HIPAA and they call it HIPAA certified or HIPAA enabled, right? And so it's super important to understand what that really means, right? So Amazon provides all the facility, right, to ensure compliance. Now it's super important on us as implementers, architects, to make sure we're doing those things to ensure that things are compliant. And a lot of the examples that Donnie just provided is ensuring that logging, monitoring, observability is there, right? So we know what's going on in the environment. Leveraging tools that identify when we got PII and PHI floating around where it probably shouldn't be, right? Mm-hmm. So those types of things as well. And then from a DR perspective, making sure that we're leveraging the facilities that Amazon provides in their services to facilitate regular testing and validating our data, right? Just because we back it up, we store it over there and we say it's air gapped, and if we never look at it again, that does all of us a disservice, right? Because then we just don't know if we do have issues. So regular testing is super important. But again, if we're smart, right, and we ensure that we're leveraging all the facility to ensure compliance, and we're doing regular testing, and then leveraging optimized compute, leveraging automation, allows us to do that testing more effectively, more quickly, right, with less friction, and just giving us peace of mind that, I just unpacked that backup and everything was good, or we just recovered this system. Not only did we do it within the recovery time objective, but everything is operating, with respect to, is operating as we had expected it to, right? No different than it is running in production today. Being able to do non-disruptive testing also super powerful in the cloud as well.
Excellent. So that's a great question. What are some of the biggest mistakes? And this is really for a healthcare organization to look ahead here. What are some of the biggest mistakes that people make when planning for disaster recovery? And how can your solutions help avoid them?
I mean, there's one of the things is the financial impact that we were talking about earlier. Implementing disaster recovery infrastructure can be kind of similar to a lift and shift move. A few years ago, there was a huge trend for infrastructure to move from on-premise, privately owned stuff sitting in companies' buildings, and migrating those workloads to the cloud. That was called lift and shift. And that was great. A few years ago that happened. And one of the trends that we saw is some of the costs were a little higher than expected. And the reason is because they didn't really think about what infrastructure customers were landing their applications on. So they just picked up their code, basically took it over the cloud and dropped it in, and then they got the bill. And sometimes there's sticker shock. And the branding police would kill me for saying this, but I think you should look at it. Lift and shift is dead. Lift and optimize instead. If you do that lift and shift and you don't do an optimization, or if you do that new deployment and you don't consider the efficiency of power, performance, and cost, the impact can be significant. I mean, on $1 million spend, we're talking about saving $270,000 to $450,000 per year. That keeps, during the next downturn, that keeps a bunch of people employed, or it enables more investment in innovation or growing infrastructure by these hospitals in order to provide a better quality of service to their communities. So that would be my take. One of the big mistakes is not considering the financial impact. Where you land those applications matters. Currently, AMD has great products in the cloud. We have leadership, price, performance, and so that's a smart place to land.
That's excellent. Thank you, Mike.
And just to reiterate on the biggest mistakes I see, mistakes is again starting with a comprehensive plan. I think the biggest thing is that we will focus in on maybe our main EHR, okay, and that is a very critical system, probably one of the most critical systems in the healthcare system. It's not the only one, right? Like critical applications include your lab systems, your integration engines that feed those, your honestly, allergies is a big deal in food. So there's a lot of critical systems there that should be included in that conversation. So the biggest mistake is saying, well, I can restore, or I can, I'm planning for one system. You need to plan for like that comprehensive set of services that are now a continuity of care. And it's usually about 5 or 6. I think I've read several reports in the past where there's about 7 critical categories. I cannot remember off the top of my head, but like lab information systems, allergy systems, obviously anything the EHR would be related, imaging systems. If you kind of focus in on those top critical workloads, and then make sure those are resilient or have the ability to be recovered as part of your business continuity planning, I think those, and then turn around and practice that. I think that's probably the way that I would recommend people to start.
Fantastic, Donnie. Moving to the lightning round. We got about 2 minutes left before we'll call it here. Real quick question. It's probably a big answer, but we'll see what we can do here. What are some of the biggest opportunities for a health system to save money when planning for disaster recovery?
Jeremy's already said it, so I'm going to tee him up since we're kind of short on time a little bit. Yep. But I would say pilot light, leverage it. It's a capability, and then use elasticity. And Jeremy, you can color in the details.
Exactly. Take a pilot light approach. Be smart about what it is that your states of recovery, right? Not everything's a tier 1 system, right? Stuff like that. So focus on those tier 1 systems, clinical systems, critical care types of systems. Start there. Get really good at it. Automation too. I'd throw on top of that too, Donnie. Right? Super key, because that makes things repeatable, and it makes your testing repeatable, and it makes it faster, less painful, right? And the more you do it, the more comfortable that you get. You're at that recovery motion, but it also helps optimize costs as well, right? The more you can automate.
Yeah, and kind of like so bringing it back home about building your business case. By the way, that was a great question. Is how do you save money with your DR planning? I think you would just go back and to that point, build out your business case. So one of the great stories that I would love to share in more detail, we don't have time, is that an organization built out this disaster recovery plan. They built out a read-only environment. they did not realize they were going to save as much money on their cyber insurance as they did by being able to demonstrate that they had this available. It ultimately ended up saving them enough money in cyber insurance costs that it paid for the entire solution itself. So it was a literally a net zero cost, delivering huge value and capability to the organization. So don't just limit the thought process to spending the money, but look at the comprehensive impact that it has in reducing risk and saving money.
Yeah, TISO is very broad conversation, right?
Yep.
Excellent.
And
Great panel,
finally, I would
gentlemen.
say, seek expert consultation when you're going to do these transformations, for example, with Atayo here.
Absolutely.
Fantastic. Expert panel, gentlemen. Great discussion. Thank you, everybody, for joining us. And certainly stay tuned for our next webinar in our Thought Leadership series. Thank you so much. Have a great rest of your day. Take care.
Thank you.
Thank you.